This chapter, the coming one, of course, is the best one when it comes to the hands-on. So that's what we covered last time. I'm so sorry. Okay, so last time we were discussing the SRS template, and it was mainly this outline that we talked about. We said not necessarily that we follow it in a structure. Sometimes we skip some of these sections, sometimes we merge them. We put another title, let's say, to address these topics, and so on. So we agreed last time that SRS is considered a contract. This contract is spread out to many people, right? All these people that you're seeing here simply get a copy of your SRS. That's why it's very important. So the customer looks into it to make sure it meets the business goal. The business analyst will double check if actually, like he will analyze and evaluate the project, okay? Does it actually does the job needed or not? For software engineers, here, why would you use it? Huh? Coding, development. Designers, of course, so you would know how to provide the design solutions. Quality assurance people. Now this is so tricky. Why would a quality assurance person need access to SRS?
To test it. So
Exactly,
sure
test cases, thank you.
To make sure it does the right thing.
Right, very good. Remember when we said requirements has to be testable, deliverables? What do we mean by this? So I cannot say this is easy to use, right? How would you make it easy to use? You need to have clear measure. I cannot say this is fast enough to process. I have to say within 3 seconds, within 4 seconds, this has to be done, right? So having a clear measure, this helps you to ensure the quality and provide test cases for your application. Project managers, they will need it mostly to know how to coordinate the work, which process to be utilized based on the resources, based on the budget, the timeline that's given to them. And of course, investors, they will assess your work and double check, is it actually something that's worth investing in or not? Yeah? That's why we see lots of startups, let's say, that could be invested on even before they start their work, just with the idea sometimes, right? All right, so this brings up the importance of validation. Let's get back into validation. We agreed every phase will finish actually and wrap up with the validation stage. So ideally speaking, if we don't get waterfall, then we're simply keeping the validation process till the very end. Yeah? Lately and postponed like heavily. So here we can say that these errors can cost a lot, right? You have one of two options, either to fix it immediately on spot when you realize that this is something wrong, or you keep waiting, yeah? You push this late into the process, and then you find that the cost is gonna double into 100 times sometimes. So delaying it is not the option. It might be just temporary start for another phase, but at the very end your pace is wrong. So this has to be, again, reinvented from scratch. So requirements validation is like making your GPS telling you if you are turning right or left, let's say, at the right time. Okay? Before or after, so just inaccurate. All right, look at this figure here. What do you see, and what's your conclusion? Any observation?
It checks if it's like valid, if it's like real,
Yeah.
authentic.
Does it work?
Fake.
It does not work.
Does it work? No.
No.
Why?
Because they check.
Everything but the main thing.
Yes.
Thank you.
Oh.
So we don't want to do this, okay? We don't want to look into features that doesn't tell us if this is the right requirement or not, yeah? We want to double check this on the right requirements. So the validation needs to be accurate, needs to be custom on the case study that you are building a solution for. So again, don't go into the false negatives. That's not our case. We need the positives, true positives. All right, how can we validate? And I think we covered some of these already before, yeah? We talked about prototyping. We said Once we have anything that's unknown, uncertain, we go for prototypes. We show it to people, we test it step by step, we test navigation, we make sure that things are now settled, we move on. A replacement could be simply doing it manually. So we review these requirements, we read through it, we simply do all our analysis manually. Yeah? So this needs to be adjusted, this is not required, this is extra, this whatever. Yeah, this is not written correctly. We just do this. Okay. The last one here is the test case generation. So again, we mentioned that we are making this validation phase mostly to double check that every requirement is testable. And I can generate a test case at the very end for it. Yeah? So if I say the system has to be, for example, supporting 100 user access at the same time, then I'm able to make this as a test case. When I say it responds, let's say, to my button clicks within 3 seconds, it has to verify this. So these are test cases. All right, that ends our third chapter, which is mostly focusing on requirements. A quick recap on what we covered in this chapter. We were talking about functional requirements, non-functional requirements. We differentiate it by saying which one,
How and who.
How and what?
what and how, exactly. Thank you. And we also talked about the SRS document, right? Like, why is it important? Who gets access to it? How to write good specification, and so on. And we looked into different techniques of gathering requirements. Any?
The Moscow method? The Moscow thing?
That's not elicitation. That's prioritization.
Interviews,
Interviews is one. Excellent.
on-site interviews.
Observations, right? Groups, surveys, like you do in the assignment. All of these, perfect. And then we finalize this with the validation stage. Now we will start a new chapter, and this chapter is mostly talking about the system modeling. So it's a very nice stage in between requirements gathering and implementation, right? So we have coding, okay? We have coding, we have requirements, we have a stage in between, like when you type, let's say, a pseudocode. It makes your code process easy, right? You write it in English, basically. So you have the steps, and this would apply to multiple languages, multiple platforms, doesn't matter. Yeah? So your design has to be abstract, has to be high level, always general, yeah? And it can apply to a lot of system types. So that's our fourth chapter, and here we will talk about three main concepts: model-driven engineering, structural models, and behavioral models. So I asked you early this semester if you know UML.
Yes.
Remember? And you said yes. What do you know about UML? Or what type of UML?
So universal modeling, something, language.
Yes, true. Any type, do you know?
I forgot.
I think the guys told me you covered it in SE120.
Yes.
So class diagrams.
Yeah.
That's it.
Yeah.
Sequence, use cases.
No.
Okay, so we know the basic at least, class diagram. Now the way you saw it in SE120 was providing the code for you and then seeing the diagrams, which is not how it goes, yeah? In real life, we do it the reverse way. So we move from requirements that are written into design. Then this design can serve as a blueprint for implementation and development, exactly. So we will see it here in the right sequence. Now we finished the first SDLC stage, which is requirements. What's SDLC? Software development lifecycle. So first stage is over, requirements. Then we are in the second one, right? That's mostly design and modeling. All right, so we will look into the model-driven engineering, and we will split the types of model into either structural or behavioral. Now looking into UML, let's say class diagrams. Which one you think it will be?
Structured.
Why?
Because it's in a very structural manner. Like it's
Excellent, very good.
diagrams.
Now keep this in mind, we will differentiate it in a while. But let us start with the model-driven engineering first. So as we mentioned, this is abstract type of modeling. By abstract we mean high level or low level? High level, which means we're not digging into deep details, Just very simple, very shallow view. And we look into our system, reflecting different views. As we said, could be structural, could be behavioral. Then we use UML to reflect it, which is Unified Modeling Language. And this will simply help you generate complete or partial system implementation. Again, keep in mind, when dealing with these stages, we're not still working offline. We're part of a process. And again, based on the process that you choose, you can either make it incremental deliverables or one-time deliverable, like in waterfall. Yeah? So here, this will help you define either its complete or partial implementation. To start off, we can classify this into 3 layers. So we have conceptual layer, logical layer, and physical layer. So what's conceptual layer? Here we have actors. Who are the actors?
Stakeholders.
Excellent. End users, right? All right, so here we have business and organization. So mostly here, we're having all the actors involved. We get to know more about the location. So my resources, are they on site? Are they working remotely? And we discussed this case previously, remember? We look into the business logic. And we look into what process we will follow. The process and the type of events taking place. So that's our highest level. Let's make it a bit more detailed. Now this is logical layer. How would you control this process? Like what? When we introduce agile or incremental model, then we say one way of managing it is Scrum or XP. Now this is a process control. Yeah? We can look into our interface. How is it designed? How is the navigation happening? And so on. We can look into services and system components. Yeah? Then last layer, which is the physical layer. Physical layer, we introduce architecture. Like what? The basic one, we know, which is client to server. So introduce this architecture. Know the configuration behind. How would you connect to a database? Is everyone allowed access, or you will have a specific access criteria? What is the network connection that's taking place, and so on. So again, high level, medium level, low level. Usually when we approach the physical model, this is the lowest level. Okay, so why do we need design? Who can tell me based on this? Now think about it like a user, think about it like a designer, a developer, please.
It allows like for everyone to basically picture how the end product might look like.
Excellent.
And to see everything like pretty clearly.
Excellent, very good. So better understanding, well done. What else? Visualization as well, you said. Excellent. Like, okay, let's look at these. So yes, we understand the system functionality. So we enhance our understanding of the requirements. Again, not everyone will be capable to read documents that you provide in 10, 20 pages. People get lost. They want the brief. And diagrams are usually the best type of visualization you can provide. People who are not technical. We ease the communication with the customer. So again, they read our work, they see it in easy fashion, they can provide feedback. We can move on with this feedback. We can discuss the design proposals. So again, how can you design your system now? Yeah, we provide extra detail on that. We help documenting our system for implementation. Like, again, think about it like a pseudocode stage. You're just typing the guidelines or the logic that this system or this component will follow. And showing interaction. So how the system components will actually interact with each other or with the external environment. So these are the reasons why we need modeling stage. Let's get started with the basic type. We call it context diagram. Okay? So what's context diagram? Something similar to what you see here. Okay? Okay. So just to give you an idea, we talked about two types, structural and behavioral. Okay? So if I told you that context model mostly show the relation between your system and other systems, identifying the boundaries of your system. Can you tell if this is structural or behavioral? That's behavioral. Excellent. The way it looks like is so similar to what you see here on top left. And these are the key elements that we will need to build our graph. We have here the first one. So your diagram needs to have an entity. This entity is usually in rectangular form. What is the entity?
Customer or stakeholders?
No, we don't involve stakeholders directly here, unless they are end users. Yes. So again, this can be a system, component, can be external system, can be hardware or software or human or object. All possible entities you might think about. Okay? So an entity in real world is nothing but an object. This object can be a hardware, can be a software, can be a human, yeah? Can be an object, like a table, like a chair, yeah? And of course it can be external system or system component. The second one is your core system. What are you building? So this usually comes once. You don't have more than one in your diagram, just one. This one can be many. Okay? And we have two types to define the relations. Either unidirectional, so you have one that represents an input and the other represents an output, or a bidirectional data flow, which means data are moving back and forth.
From input to output.
Not necessarily input output, not necessarily. Could be just data that are, let's say, undergoing AI algorithm stage. Like you process data. So remember when we said we have hierarchy of data? We move from data to, for example, info to knowledge to wisdom. So your data can be sent, let's say, to a server that runs an AI algorithm. It gets back to you as an information. And from information, it gets back to you as knowledge. Or let's say it can forecast the decision, let's say, for later, and so on. Now let's see some of these examples. ATM machine, we all know it, right? What do you see in an ATM machine? Can you tell me how it works?
Basically, you put the card inside the ATM.
So you have something that deals with the card. Excellent. What else?
And then you try to put your pin.
Place to put in the pen. Excellent.
Just what you want to do. Withdraw.
What is that?
Just what you want to do.
A screen that shows you some options. Excellent.
And
Very good.
Withdraw
Huh.
If you withdraw, you have to take the money out.
A place to take the money from. Okay.
Exactly.
And a place that gives you the reset. Yeah. By the
The
excellent.
receipt as well.
The reset. The reset. Exactly. So that's simply what builds up your ATM machine. Now you figured it out. Okay. So now we have our core system, which is ATM system. This one deals with card reader, making sure that whatever card you provide is an actual Visa card. We have, okay, forget about this one. We have a printout dispenser. So this can be for the reset part, cash dispenser for the money when you get it. We have accounts database, verifying that this is a right user for this bank. Control system overall, and the keypad that you enter your pen on. Yeah? Now looking at this one here, this is input or output? The keypad. The keypad. That's input. Like a keyboard actually here. Yeah? That's an input. So we only see here one arrow that points towards your system. Yes? Which is simply telling you commands and data, whatever you provide, numbers. Now we have, like Clean mentioned, we have the display. Yeah? Display screen. So this is now only an output. So you get to see data on it. True? Some others might be just back and forth. Yeah? So some transactions, some data might be flowing in between the ATM, let's say, and the printout dispenser to get your data printed. And so on. Here, for example, with the cash dispenser, you have the cash details, the warnings, again, back and forth. Okay, moving to the second one. So again, this one is nothing but a system and components. Make sense? Now this one. I have the booking system, that's my core. And this one deals with a guest. Guest in that case is a user, exactly. So it's a physical human or object. And we have rooms. Again, this is another object. So these two are external. They're not actually part of that system, but they deal with the system. We call them actors or entities, okay? So here we have external system that deals with your own. Like when we say Moodle, Panner, what else? My Al Faisal. These are three different systems. They all synchronize data, right? They all share data back and forth. That's why when you enter any, it's up to date. Whatever courses you register and let's say on Panner, reflects automatically on your Moodle. Yeah, makes sense? So now your system deals back and forth with another system. And it could have one module which is booking. So it takes care of the booking process itself, like a transaction. And again, back and forth, inputs to outputs here. We have, let's say, like here, you're requesting a booking as a guest, you get back the confirmation, yeah? And so on. Third example, now we have our system dealing with 6 other systems. Okay?
This is a type of systems of systems?
That system, thank you, excellent. Yes, same comment, I got it from the mail side. Exactly.
That's an example.
That system of systems, yeah. Okay, so now I have, I don't know, that's mental care, whatever. It deals with the patient record system. It deals with the appointment system, prescription system, admission system, healthcare statistics, management reporting systems, and these all, again, are built in to work with this one. Now you will not see inputs, outputs here. Why?
Is this a structure?
It's a whole system. A lot of things are back and forth, yeah? So again, we consider these, as you mentioned, system of systems. But again, this is one type of context. By the way, all the 3 types we're seeing so far are different. Do you notice?
Yeah.
This one is just a breakdown. Yeah? This one is people, objects, external systems. Yeah? Modules. This one is system of systems. Yeah? Let's see the last one. That's a library management system. We have here all mostly humans, like staff, student, supplier, and of course some attached data sets. So here I can request, for example, the student information and I get a report in return. So you just declare what's input, what is the input, what is the output, in simple words. Okay? Okay? Down. Clear till that point? Any questions?
What's the difference between the double arrows and the single arrow that points both ways?
Okay. Most of the time, when you have one that's in, another one that's out, this is input output. Okay? But here, mostly this is a data flow. Like when we say there is a request and response, let's say for the server. This is one streamline, okay? So I have to expect something in return, but it's not necessarily data. So here I'm having information sent, reports getting back. This is an output. But here, a reply, let's say, is not necessarily something visible. Could be rendering a page for you. Yeah? So it's data processing in between. We call this data flow. So making sure that I enter, let's say, the right credentials, and I get access to the right system page, and so on. So this can be simply data flow.
But does that mean we can see as well the request, the reply, everything? Is it
Not necessarily. Like when you request anything on the browser,
Yeah.
do you get to see the requests and the responses? No. Sometimes you do. Sometimes. For example, I will enter. Like, let's try any fake URL, just anything. I'll try alfaisal.org.sa. What is that? That's a response.
Yes.
It's coming to you from where?
Attachment?
The server side. Yeah? The server is telling you, okay, we can't reach this page. You're requesting a domain that's not there.
Yes.
Yeah? So sometimes we see it when you get, for example, a message saying 404,
Oh, yes. Yeah.
page not found. This is an error coming to you as a response from the server side. Okay? When you see redirection, sometimes a page is moved, let's say, to another domain. And when you try to access the old one, it gets automatically moving. Yeah? These are happening responses, but you don't get to see it. When you get actually the same page you're requesting, this is success response. Return it back to you into from the server side. So sometimes you get responses without you see it. Okay? But it's part of the data flow back and forth to make sure that this system works. Clear? All good? All good? All right. All right, so let's classify our models now into two different types. One that I will call it structural, and the other I'll call it behavioral. Okay? Structural means what? I can see the inner structure. Okay? So I will just make it easy on you. So we don't need to know all of these models. Your focus as a software engineer needs to be on this. I mean, these are quite similar. We'll discuss them. Activity, sequence, state, use case.
Doctor, what do they mean by sequence?
We'll see. Each of these is a different type of diagrams, okay? But from what the name suggests, this is more concerned of the sequence of transactions you're sending, okay? We'll talk about each of them separately. Okay. All right, so if we will classify now context, where to put it? Excellent. So it's here. Thank you, Noura. Next goes here, right? So, class diagram, which we know already from before, and as you mentioned, this is structured model. It's a bit cold. You're feeling cold? Yeah. Okay, I can send the facility a note if you want. You can bear it? It's okay. That's CL 416. Yes. 5 minutes. This was all right. Okay, so back here. All right, so class diagrams is what we explained earlier, SE120, remember? In 120, whatever, all other courses. We will discuss now these one by one, okay? But let me just give you a quick hint what to expect inside. Structural in general, we call them glass box modeling, which means what?
You can see the.
I can see everything inside. It's a glass box, okay? On the other side, behavioral, it means
Black box.
black box. Like in the context diagram, let's refer back to that example. We can see, for example, ATM, we can see card reader, we can see, what was it? Dispenser, let's say for cash. Do you know how is it built? Can you see that part of the diagram? It's a black box. So we don't know how it actually processes data. So for us, it's only a black box, okay? Glass box on the other side is open arm. You can see everything inside, okay? So this is simply like when we say, how is our code structured? Is it all in one class? Is it subdivided into inheritance infrastructure and so on? So let's look into this in action. I'll get now started with the class diagram, which you know already, right? Let's look into more details and rules behind. So we have this simple structure. We have 3 portions. First one is usually the name. Second one is list of attributes, right? With a sign before. So do you know what are these? This one indicates.
Public.
Excellent.
Minus is private.
Excellent. Hashtag is.
Protected.
Excellent.
something underneath.
Clear.
Abstract.
One more.
Abstract.
What is that for?
Default.
You know the curly sign? This is default or package.
default ما بيكون لها أي شيء.
Yes. No, we do this. Has to be curly one as well. Okay. So now, and of course you can represent still the abstract by name italic. Okay. Now, third part is mostly
Constructor and methods.
properties. Exactly, methods. So here we look into the name of our method, if there is any possible arguments in between. And by the way, this is even shortened. So this can be name, string, right? And last one,